Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about practical tips to securing your DevOps pipeline. Previously, we've talked about securing a DevOps pipeline with our CTO of Intel Federal, Steve Oren. Today, I'm going to talk about some practical tips to carrying out what Steve and I talked about 4 episodes ago. So the first thing we want to do is to take a look at the different types of attacks that are out there and how we're going to focus our DevOps pipeline to circumvent those attacks. So a lot of attacks happen at the people level, and some of the most insidious attacks that we recently have had in the last year focused on phishing and social engineering attacks on individuals inside DevOps organizations. We've got to do a better job at training our people. In this case, it was an intern. That one's a hard one to do, right? You've given an intern access to the keys of the kingdom. That's something that should be looked at. Another type of attack that we see a lot of is your technology attacks, your traditional denial of service attacks, SQL injection attacks, or buffer overflow attacks. These latest attacks use both people and technology to attack the process. And these attacks are even more insidious because they're happening especially around the build process. These attacks can be very hard to find, and also they can propagate really malicious code throughout all of your customers. So securing that pipeline, that supply pipeline is going to be something that a lot of companies are looking at more, and they may want to come and do audits inside your build process. So we've got to come up with a strategy to help out with that and to show your customers that you do have a secure build pipeline, as we've seen an uptick in these types of attacks recently. So let's take a look at pipelines in general, just build pipelines. In general, now not every pipeline is the same. In fact, if they were, then this would be a moot point. But in general, they consist of typically 4 stages or groups of stages. Development, where I'm checking in code, I'm building the software, I'm running tests, and then I move to production. Those 4 stages and those groups of stages can easily be broken down into multiple stages depending on the type of product that you're developing. But there most definitely are environments that tie to those different stages. So when we look at this whole process here, I have hardware, I have software, I have process involved. So we're going to have to take a different approach to securing this because we have to secure all those different areas instead of just focusing on infrastructure, which most people have done quite effectively. So let's take a look at this first one, which we would call let's secure our hardware. This is the bottom of the stack. So this means that I have to secure the hardware in my dev environment, your development machines, my build environment, which in a lot of cases people forget about. Your test environment's a little bit different because you may actually want to run some tests that actually inject malicious code and see how you handle that. So we'll talk a little bit about that. And then also production environments, which most people do a pretty good job at locking those down. Especially now that more and more companies are offering software as a service, you need to make sure that you are monitoring and doing all the typical things that you would do in a production environment in your SaaS environments. Let's talk about the 3 key elements in these environments that we need to focus on. First, we need to do detection. Now, almost everyone has service logs using something like Splunk to analyze logs to look and see if there's anything outside the ordinary going on. That detection and remediation is a very well-known thing. Make sure that you do this in not just your dev environments, but also your build and production environments. Now, test environments on this, on prevention or detection, may be a little bit different because you are going to be pushing your testing beyond the normal bounds of operation, including security testing, which we'll talk about shortly. So you can't just peanut butter, hey, I'm just going to run everything into one domain. It's what we found, it's good to have different security profiles, including detection, because you could come up and make your test environment not very useful for running those types of things. Now, you can also have multiple test environments where some are more secure, some are a little bit less secure on the detection side because you're actually going to be injecting erroneous things in there. So keep that in mind. Don't just peanut butter security across all the environments. They are different for each kind. The other thing that we like to talk about is we like to talk about prevention. Now, prevention comes in many flavors. The flavors I like the most are make sure that we're doing smart things with our hardware as far as making sure things are patched properly, you have the right security updates, and that is done in an automated way. This should happen across all of your environments, the security updates, including your test environments, and especially your build and production environments. Another thing that we add in here on the prevention side is something we call a hardware root of trust. And we can establish a chain of trust from the hardware all the way up through the firmware, the boot sectors, all the way up into the hypervisors, the operating systems, all of that. So what's important here is that if I do establish this hardware root of trust through the stack, that I carry it all the way up into the development environments that my developers are working on, the build environments where things are being built, and my test, and of course, production. This can include secure containers, secure virtual machines. There are great technologies out there that allow you to do this today. I really like storing my encryption and my hash keys in hardware, in like a TPM module, and then also with some new technology like Secure Guard extension from Intel, I can store my hashes in there as well. This means that even if someone got onto the machine, they're not going to be able to steal those keys, which is important. So this ties into that zero trust model that we hear a lot about. So key here on host and infrastructure security, make sure that you're doing the same things you would do in production, detection and prevention, remediation, that you're doing in all the other environments. Next, we need to actually set up trusted executables. This means that the code that my software engineers have checked in and built, that I can run security checks against and then actually check in the hash with those changes. This will give me the ability to detect if there's anything that's been injected into the code base during the build process. Now, the build process itself should not be making changes to code. Maybe it can inject in a version number or something like that, but other than that, it really shouldn't be doing anything to the original code. This is where you can easily create these hashes that I can check against to make sure things are what they say they are. Now, the other important thing here is that we injected in here a new step or a new stage called security checks. In this stage, I can run static analysis on the code, and I can run dynamic analysis on the code for security violations. There are some great tools out there that do this today, and they're fairly easy to integrate into your typical DevOps pipeline, whether you're using Jenkins or you're using GitHub workflows, whatever the case may be, Circle CI, whatever they are, they're pretty easy to add as a step or even a stage in your development pipeline. The key thing here is that once your executable is built, create the hash right then and there. And that hash should be versioned with the executable. I'm a huge proponent of checking in executables, especially when they've been hashed, because that executable that I've created in my build should be the executable once it's gone through all of its testing that gets pushed into production. And that hash is going to guarantee that it is the same and hasn't been monkeyed around with by some intermittent process in the middle. So key here, once you create your executables, hash them up and make sure you're checking those hashes when you move into production. Now, the next area that we want to look at is what we call attested images. Now, typically we have multiple repositories to put our code or our executables. At the minimum, I would say you need at least two. A pre-production registry where the builds and the executables, this could be in the form of container images, VM images, or binary files, jar files, zip files, whatever they are, right? The key here is that my hash is created at the build time, and now in the registry, I can actually attest these and that I am securing those images so they can't be modified and changed. I've seen people do this before. I have done this before in the past where I do have an executable in there. It has the version number. Everything's all tied together, and someone says, oh, I forgot to do something. And I said, oh, it's just a label change, maybe, or metadata. So what do? We open that up, make the change, and put it back in, giving it the same version number. This is bad. This is really, really bad. Don't do that. It's better to go through your cycle, again, even if it takes a little bit of time, than to have manual processes in there mucking around with your binaries. You don't want that to happen. Now, the cool thing about this is once your tests have run, now I can take that same binary that I've run all my tests on, and I can push it to production. Now, I've seen some people in this stage actually do a rebuild of the source code. I actually think this is a mistake. I think it's best to take that original build that you created at the beginning and push that into Gold or your production repository. This repository is the only place that images, binaries, VMs, whatever they are, should be retrieved for production or pushed out to production. This golden repository is where you want to make sure that you've notarized and attested those images. Now, this is also a great place that if you have highly confidential VMs or applications that you want to be guaranteed only land on certain hardware, you want that kind of lockdown, this is where you can encrypt those VMs, containers, or even binaries, and lock them with a key that is stored in your build system and also in your production systems, a shared key. By doing this, now you have the ability to push out binaries, VMs, containers, whatever it may be, to specific machines in your infrastructure, whether it be in the cloud or in your data center itself. This gives you another level of locking things down if you have highly confidential applications and or services. Now, the other thing that we should go back to is I need to inject security tools into my build process. Now, this may sound pretty trivial. Oh, I got to use security tools, get my development team to do that sort of thing. What we found here interesting is we found a lot of teams will recreate security libraries that already exist, or they'll grab some open source ones because they were easy to access. This is where your security architecture and your security engineers need to have a say, and they need to be involved in the development process so that they can put these tools out there so they can be easily consumed by your dev teams. Great example on this is just basic authentication, user login. Why does every application think they need to create their own? Don't know. There should be a common library that should be used for that. Audit, logging, all those things are great tools to look at for reusability. So you need to treat your security libraries and tools just like you would treat other applications that you want to build reuse in. I've also seen services created that can be tied in as a sidecar container, for example, that's running alongside other containers as they move into production that can monitor and do things like that. This is a great place to inject that in. It's important that you treat these security libraries and tools much like you would any other software development program that you are sharing across your organization. And I would hope that you are sharing. This will decrease the amount of time and also increase the security across your whole ecosystem. Now, there are some other things that we need to talk about. This one's really important. We already kind of talked a little bit about this. It's the build once, deploy security everywhere concept. Once you've established your security teams as development security teams, make sure that you are injecting these policies and these tools in all of your products and in your environments. There's some great technology out there today that lets you manage multiple environments. So when a new application is spun up, that it is spun up in a security profile. We can see this being done with creating your own VM images as base images that development teams are using to deploy applications in. This gives instant security compliance in a lot of aspects. Right? So configure it into your VMs, your base containers. That's a great way to go. There's also the ability to integrate with security tools. So that if I do catch anything in the application outside the ordinary, that I am either projecting that out in a log in a certain way, or that I'm calling an API to a security detection tool. Also, do not try and create security tools that handle 100% of the cases. You will never finish them. Go for the 80%. That will be your good, strong baseline on these tools and libraries that you create. And then create them so that your application developers, if they do need to innovate, that they can innovate the last 20% in conjunction with your security team. That's another really interesting part here. For me, I would love to have a security engineer on my Scrum team and developing code with my other developers. I think it's important, especially now with security being a hot topic for 2021. And then last, and probably one of the most important things, automate everything that you can, especially in your DevOps pipeline. If you have someone that's in there injecting things in there, that's going to cause problems. That's a potential for a hacker to get in and cause chaos. Another thing that I tell everyone, check in your pipeline, version your pipeline, protect your pipeline, protect that process. We've seen in the last year and a half, and more recently in the last 4 months, we've seen pipelines and processes injecting new steps in the process to insert malicious code in the process. And no one was paying attention. It was just happening. Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and do something wonderful.